In the last video, I ended explaining the formula that delta G is the sum of the delta G of formation of products minus the sum of the delta G of reactants, very much like we have done with delta H and delta S. In addition, we're now going to be looking at whether a reaction is considered to be spontaneous with mostly products, non-spontaneous with mostly reactants, or at something that's at an equilibrium. And so it's either a small negative or small positive value. So basically from a minus 10 to a positive 10. Okay. So now we're going to do another example. Okay. All right. And so these are the same reactions we just did, but now I have a delta G of formation table down here. So the delta G naught is simply going to be, again, it's the products minus reactants times coefficients. So 6 times the delta G of formation of HF plus the delta G of formation naught of SO3 minus the delta G of formation for SF6 naught plus 3 times the delta G of formation for the water. Okay, so that my delta G naught, now I'm going to get the values from the tables. So I have 6 times a negative 274.6 plus a negative 371.0 minus a negative 1396.1 plus 3 times a negative 237.1. Again, these are all values from this table. Okay, so my products end up being a negative 2018.6, and my reactants end up being a negative 2107.4. Okay, so my delta G naught for this equation is 88.8 kilojoules. So according to this is non-spontaneous. And would be mostly reactants, so this would not go forward. Now, if you go back to the other video, I will recognize the fact that from the previous video, from part 1 of this section, we found that from using the delta G is equal to delta H minus T delta S, we found that the delta G was a negative 190.6 kilojoules. And the only explanation I have for this sometimes happens, and it could be from the fact that the numbers were gotten from different sources, which goes against what I said for the fact of having a standard delta G, but that's the only explanation that I have. Okay, and I know in particular that I looked up, our textbook does not have sulfur hexafluoride in it. And so I looked up these values from the internet, and I know that they came from 2 different websites. So that would be my explanation as to why we got such 2 different values there. But it does happen. Even I've had it happen even with using values from our textbook. Okay, so we're going to do one more problem, and it behaves better, if you will. Okay, I'm going to black this time. So delta G naught is going to be the 2 times the delta G, whoops, I did that before, of formation for the iron 3 sulfide, or oxide, sorry, plus 8 times the delta G naught of formation for SO2. So my products minus 4 times my delta G of formation for the iron 4 sulfide plus 11 times the delta G of formation for O2. Okay, So I'm going to get these numbers. Okay, so I have 2 times a negative 274.6. Oops, I'm sorry. I'm getting the wrong. It was 2 at least. I was looking at the wrong paper. Problem with writing out my problems beforehand. A negative 743.5 plus 8 times a negative 300.1 minus 4 times a negative 160.1 plus 11 times 0. Okay, so the delta G naught for my products is a negative 3887.8 kilojoule, well, minus. My reactants is a negative 640.4. So when I add those two numbers together, I get a negative 3247.4 kilojoules, which is definitely spontaneous. That's a very large negative number, which means it's mostly products. I would say as high as that number would be all products, but okay. And compare to the previous video, that was a negative 3,247.9 kilojoules. So those two compared very closely. And these values all came from our textbook, but like I said, I have done problems that even values from our textbook give me 2 different values using 2 different methods to calculate it. Okay, so that is the end of this section for the textbook.